Good day and welcome to another physics lesson with Mr. Simons. Today we're looking at grade 10 electrostatics. I'm answering a question from April 2021 set up by the KwaZulu-Natal province, right? Question, because it's so long, I've broken it up into three parts and we'll answer the three parts separately. So there, 2.1, what's meant by triboelectric charging for 2 marks. Give me three metal spheres are placed on an insulated stand and carry charges as shown below. Minus 3,2 times 10 to the negative 17 coulomb for A. Minus 4,8 times 10 to the negative 19 coulomb for B. We have negative 1,4 times 10 to the negative 19 coulomb for C. 2.2.1, determine the number of excess electrons found on sphere A. So there we're testing, do you remember that the charge of electron is 1,6 times 10 to the negative 19. I'm going to divide the two to get the amount of electrons. 2.2.2, is it possible for the charge encoded on sphere S or C to exist? State yes or no and give you a reason. Right, so basically we're testing, do you understand what is the smallest possible charge something can be? And then the principle for why that is so. So you can attempt to answer these first three. I'm going to answer them in the next video before I go to the second set of questions and the third set. Alright, so triboelectric charging is simply a process by which objects are charged by contact or rubbing. 2 marks. Something you experience if you walk around in the house dragging your feet and not picking them up. Every time you drag them, you lose electrons, you become positively charged. When you touch something neutral in the house, you experience a small shock. Right, so that's triboelectric charging, charging yourself by contact or rubbing. Now the three metal spheres there given. Determine the number of excess electrons found in sphere A. So we need to know the number of electrons N equal my charge given divided by the charge over electron. So we have minus 3,2 times 10 to the negative 17 coulomb divided by charge of electron, which is minus 1,6 times 10 to the negative 19, and we divide that 2, we get an answer of 200. So there's 200 excess electrons on sphere A. Right, so you need to know this. We'll test it over and over. Is it possible for the charge engaged on sphere C to exist? State yes or no and give a reason. Number one, it's no. Because the smallest charge that can exist is 1,6 times 10 to the negative 19 coulomb, and that is smaller than 1,6. So therefore the charge can't exist. Alright, so some nice application theory questions we need to understand. The principle to explain this is called the principle of charge quantization. Right? So that's the principle of charge quantization. It explains why the smallest charge is 1,6 times 10 to the negative 19 coulomb. That's for my electrons and protons. Right? And we can't have something smaller than that. Okay, I shouldn't go into deeper physics. Right, now second set of questions. Now they say we have two identical metal spheres and they are placed on an insulated stand as shown below. That insulated stand is just so that it doesn't lose its charge to the earth. Right, now sphere A carries a charge of minus 6,4. N here stands for nanocoulomb and sphere B is uncharged. What is meant by sphere B is uncharged for 2 marks. Then the sphere says sphere A is now brought close to sphere B. So I take A and I bring it close to that, but it's not charging. The spheres do not touch. Draw a sketch to show how charge distribution that takes place on sphere B. So this item is negative, it should attract the positives closer to it. Now the side should become negative. Name the phenomenon as described in question 2.3.2. Then eventually the two spheres touch each other and they separate. They want us to state the law of conservation of charge and calculate new charge on each sphere after touching. So this 3 marks, a very common question. So let's look at the answers. So for something to be uncharged, we first need to understand that then the amount of electrons and protons I have are equal, right? Therefore, it can't have a positive or negative charge. So there, number of electrons equal number of protons, 2 marks. All right. Sphere A is brought close to sphere B, so sphere A is negative. Negative electrons should attract positive particles. No? So when I'm drawing the sketch for B, on my left hand side, my positive charges should be relocated there, and my negative charges on the right hand side. Right, if you swap this around, it's not correct because negative can't be attracting negative charges in the second sphere. So if that's correct, the positive and the negative, that is 2 marks to show charge distribution. The phenomenon described in this question is called charge polarization, meaning I separate the charges and create a polar item, meaning one side is positive and one side is negative. All right. We'll do it more in detail in chemistry when we look at polarity and intermolecular forces next year. All right, now let's go to in the next question. They said sphere A carries a charge of minus 6,4 nanocoulomb. A touches B now. All right, so they've made contact. Law of conservation of charge state the total net charge in an isolated system, very important, meaning nothing from outside interferes, remains constant during any physical process, 1 mark. 2.3.5, calculate the new charge on each sphere after touching. So formula, Q new, charge 1 plus charge 2 divided by 2. Right, so we have minus 6.4 nanocoulomb plus 0 divided by 2, which then gives me minus 3,2 nanocoulomb. So basically after touching, both A and B will have a charge of minus 3,2 nanocoulomb, and therefore they would repel each other naturally. 1 mark for correct formula, 1 mark for correct substitution, and then last mark for answer. Right, now the third set of questions is also my just application question. Refer to the 6 spheres A to F below. Sphere A, this one here, is positively charged. The other charges on the other spheres are unknown. A learner wishes to determine the nature of the charges in the other 5 spheres. She makes the following observation. F attracts both A and B. So if A is positively charged, for F to attract A, F then has to be negatively charged. B automatically will have to move to F because of A being attracted. D repels C, so therefore C and D have the same charge. But E attracts D but repels F. So F is negatively charged, therefore E must also be negatively charged. For it to repel F, that means D should then be positively charged. Alright, C attracts B, but it's repelled by D, so if D is positive, then C is also positive. A is negative, so that means that B there can technically say is neutral. Alright, so we look here, as I said, B is neutral, C is positive, D is positive, E is negative, and F is negative. Hope you understand the explanation I gave to you. So, as I said, F attracts A and B, so the only time two charges attract each other, this one is positive, that one must be negative. Therefore, F is negative. Alright? E repels F. So for E to repel F, they must have the same charge. So if F is negative, then E is negative. Right? But it attracts T. So for E to attract T, if E is not positive, E is negative, then T should be positive. Because positive and negative attracts. Alright? So therefore T is positive. T repels C, so T to repel C, they must be like charges. So if T is positive, then C is positive. Right? C attracts B, so therefore B in this case is a neutral charge. Alright? Hope it makes sense. God bless. Wish you nothing but the best. Make sure you know your theory. Make sure you know how to work out new charge and amount of electrons. That question appears over and over in our past exam papers. God bless.